Hello, welcome to this video. Hopefully it will help you. This is the Section 3 Science 9 Chemistry Review. So this is for my students to help them understand and review Section 3. Topics include ionic and molecular compounds, naming them and writing out their formula, counting atoms and elements, drawing molecules according to the periodic trend of atomic radii, and how we not draw ions, but what are ions, and what do we call an ion that loses an electrons and others that gain electrons. So let's deal with naming compounds. Okay, so the best way to do this is just go ahead and let's get an example here. So what if I had, let's say I had CH4. Okay, so if I had CH4, I know this is not the best, but right, my first step I have to do is determine if it's ionic or molecular, because we all know that molecular and ionic compounds are going to be named by a set of different rules. So we ask ourselves, okay, is this a metal or a nonmetal? And we know that's carbon. Carbon is a nonmetal. And hydrogen, is that a metal or a nonmetal? We both know that hydrogen is a nonmetal. So if we have two nonmetals together, we know that this compound is molecular or non-ionic. Okay, so the first thing we need to do, we got to remind ourselves, sorry, the other things we need to do is remind ourselves of the rules. So the rule for molecular compounds, it's not that confusing. Okay, so the first element, or sorry, the first atom of the element, just it remains unchanged. Okay, right? It's carbon. Now we only have one carbon, and when we're naming these compounds, molecular compounds, we have to follow adding the rules for adding prefixes according to number. So mono is 1, di is 2, tri is 3, right? And so on and so forth. Okay. Tetra is 4, hepta is 5, hexa is 6, hepta is 7. Sorry, penta is 5. I meant to say penta is 5. Penta is 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Okay. Now, what a lot of people might look at and they might suggest to do is that since they have one carbon, they're going to go ahead and do monocarbon. But you don't do that. Okay, you don't do monocarbon, and you don't add the prefix mono to the first element ever. Okay, the only time you ever add a prefix to the first element is if it has 2 or more atoms. Okay, so if I had C2H4, then that would be different. But since I only have one carbon, I leave it as it is. Okay, and the next one, it's very similar to ionic. Okay, but you have to start with a prefix because this is molecular. So we have 4, so we're going to use tetra, right? So it's going to be carbon, tetra, hydride. Okay, carbon tetrahydride. Okay, so what we do is to get this is we take hydrogen and we drop the ending and we add IDE. And that's how you name a molecular compound. Okay, now let's do another example. Let's suppose I had similar. Let's say I had C2H6. Okay, let's just do that one. So carbon, is it a metal or a non-metal? It's a non-metal. Hydrogen, is it a metal or a non-metal? It's a non-metal. So we have a molecular compound. Okay. All right. So what we're going to do is we're going to take our first element and leave it unchanged. But oh, look at this. It has 2 atoms. All right, that's 2 or more. So we have to use a prefix now. So it's dicarbon. Okay, and hexa for 6. Hydride. There you go. Okay, dicarbon hexahydride. All right, so let's try different molecule here. And oh, I guess I'm gonna have to erase everything else. Just bear with me. Erasing, erasing. How come this doesn't erase? Okay, there we go. Good. Erasing, erasing. Yes. Okay. All right. Oh boy. All right. So let's say we had a compound like let's see if I can think of a compound here. Okay, let's say we have, let's do two of them. Let's say we had, oops. Let's try this one here. Oops. And let's say we had, all right, so let's do the one on the right first. Okay, so this is not too difficult of an example. So first of all, is lithium metal or non-metal? We notice that it's on the far left side of the periodic table, so it is definitely a metal, and chlorine is on the right side of the staircase, so that is definitely a non-metal. If we have a metal and a non-metal, that is an ionic compound. Alright, so ionic compounds are going to follow different rules compared to the molecular ones. Again, we're just going to start off with the first name of the first element we see. The metal always goes first. And we have it lithium. We leave it unchanged. Okay. Our second atom of the element is chlorine, but we have to change that. So what we do is we do the same thing we did for molecular. We drop the INE and we add IDE. So we have lithium chloride. Okay, and that's how you name an ionic compound. Okay, now this guy is a little bit tougher. All right. So for this one, if we look on our periodic table and we look at the charge for iron, the possible charge for iron is, well, actually I should back up. First of all, iron is a metal, okay, and oxygen is a non-metal. We know that, so this is going to be another ionic compound, okay. So this is the other kind of ionic compound that we can find, but we have to look on the periodic table, and we find that iron can either have a charge of +2, oops, +2, +2, or +3, okay. And oxygen is going to have a charge of -2, right? And we could see that if we just take a quick look here at this -2, and we do an old switcheroo, right? And we take this 2 and we put it down here, right? We see, why is this thing appearing? My goodness, come on, go away. Go away, thing. Man. Alright, right? And then we see that, so which is it going to be on the iron? Is it going to be the 2 plus or the 3 plus? All we got to do is just look at the amount of oxygen atoms we have, right? We have 3 oxygen atoms, and we do the old switcheroo, of course, when we're doing a formula for compounds or molecules. Oh, there it is again. Okay, and this is what we do: is we do the old switcheroo, and we go down this, like that. Okay, so that means we can work our way backwards. So if we go 3 to +3, we notice that this iron has to be +3. But because iron has a possibility of 2 charges, when we name it, we have to declare the charge on the metal ion always. So this is how we do it. Okay, we go iron, it's unchanged. The metal goes first, it's unchanged. And we put in brackets the number of the charge on the metal, which in the case is going to be 3. And then, of course, we know that this is oxygen. Okay, drop the ending and we add IDE. Okay, and it is iron 3 oxide. Okay, so those are some examples of how we name ionic compounds. Okay, polyatomic ions also follow the same sort of rules. Okay. Okay, so now what we're going to do is we're going to take a couple examples and we're going to work backwards. Okay. Erasing, erasing. Okay. I don't know any faster way of doing this. Oh boy. I have so many markings. Oh, erasing. There you go. Okay. Erasing. Come on. Is there any faster way of doing this? Oh. Okay, dokie. Now, here we go. So let's go the other way around, okay? So let's say we have a compound like, oops, let's say disulfur, trichloride, okay? Disulfur trichloride. First of all, we can see right away, because we are using prefixes, that it's going to be a molecular compound, okay? So disulfur, this prefix means 2. So we're going to have 2 sulfurs. So that means it's going to be disulfur, trichloride, chlorine is Cl, and there's 3 of them. So there you go. Okay, so we'll take this one step further, and we'll explain, how to count atoms and elements. So one question that they can ask you on a test is, how many elements are there? Okay, and so the elements are just the basic building blocks of all matter. And we see that we have 2 elements. We got sulfur and we've got chlorine. So the answer for that is 2. Okay. Another question they can ask you is, how many atoms do you see here? Well, that's a little tougher, right? The atoms are the things that make up the molecules. Okay. No. Here we have, and it always denotes, the number of atoms always denoted by the subscript here. So we got 2 sulfur atoms. Okay. We got 2 sulfur atoms. And we got to add that to 3 chlorine atoms, which gives us a total of 5 atoms. Okay, and the other question is, how many molecules are there? What are the number of molecules? Oops, okay. So the number of molecules is just how many, say, of these substances that we have. So this is all one large substance, okay? So we have 1 molecule, okay? And of course, because it's made up of sulfur and chlorine, they're not atoms of the same elements. Because of that, they're different atoms of different elements. They are more specifically called compounds. Okay? So I'll give you an example of a molecule that is not a compound. Okay? Hydrogen is an example of a molecule that is not a compound. Okay? Hydrogen in nature is found like this, H2. It's got 2 atoms of hydrogen. Now, it is called a molecule because it's made up of more than 1 atom, right? But it cannot be a compound because it's only made up of hydrogen atoms, okay? So this is a molecule, but not a compound. All right? Now, if I were to go ahead and change this a little bit, so I have my eraser, that was a lot easier. So if I take that and I go H2O, aha, now I still have a molecule, right? But the question is now, oops, question becomes, do I have a compound? And the answer is yes, I do have a compound because I've got atoms of hydrogen and atoms of oxygen. They're different, therefore this is a compound. Okay? Alright, let's do another example here. So we did disulfur trichloride. Okay, molecular compound, pretty easy to see. It's got prefixes, you know right away that it is molecular. But the ultimate test, of course, is asking if you have 2 nonmetals. Okay, if you have 2 nonmetals, then it's molecular. Okay, erasing. There we go. It's not too bad. I wonder if these are a little. I can just get rid of them. I don't know if they're just dots or dust on my computer or things that I can erase. Anyway, okay. So let's try one more. Now let's say I have. Um, say I have calcium phosphate. Now this is a little bit different. Okay, so in order to do this question, you're going to have to know some of your polyatomic ions, right? And so what we're going to do is polyatomic ions for our purposes is going to be an ionic compound. Okay, here we have a metal, and this whole thing is a non-metal. So calcium, we know right away that we can represent it as Ca. Okay, and if we look on our periodic table, it has a charge of 2+. Okay, now phosphate, we have to look at our polyatomic ions, and in case you don't remember what it is, a phosphate is a polyatomic ion. It's phosphorus, 4 oxygen with an overall charge of 2-. This overall charge of 2- belongs to the phosphate and the oxygen, the whole thing, not just the oxygen, not just the 4 atoms of oxygen. Okay, so here we go. We've got calcium 2+, and we've got phosphate, okay, which is 2-. Now we got to figure out what the chemical formula is going to be. So a compound or a molecule of a compound, the way they go together is they get together so that the overall charge is 0. Okay, so if I have 2+ calcium, I have to figure out how many phosphates I can have so that I can have an overall charge of 0. Okay, so if I have positive 2 and I'm going to add it to some number x, I have to get 0. Okay, and that number x, if I solve for this equation, has to be -2. Well, we're in luck, okay, because -2, if you look over here, -2 is the exact same charge on the phosphate. So that means for every 1 calcium, we need 1 phosphate to balance out the charge. So then what is our molecular formula going to look like? Well, it's going to be calcium phosphate. And there you go. Okay? And that's an ionic compound with a polyatomic ion. Okay? All right. The other thing that you're going to have to know how to do is how to draw molecular compounds. And the thing you need to know about that is just the periodic trend for the size of atomic radii. So as you go from the top part of the periodic table, okay, as you go in this direction, okay, the radii increases, okay. So the radius of the atom increases, okay. And as you go from, it's already written here for you, but as you go from right to left, right to left, okay, the atomic radii, okay, so the radius increases, right? So it's easy now, right? You know that periodic trend. If you were to compare the size of, let's say, beryllium to the size of oxygen, okay, you would know that beryllium would be larger. So if you had them arranged in some sort of molecule, you would have it looking like this, more or less. So beryllium would probably be this big, and then oxygen, right, that's bonded to beryllium, okay, would be smaller, okay, and you would have to draw that, okay, and that's all that you're expected to know how to do at this level, okay. There's something called the Vesper model and all that sort of bonding stuff with pi bonds and sigma bonds and all this kind of stuff that you don't need to worry about right now, okay. Alright, so that's something you're expected to know. So if I asked you what's the relative size, or order these elements, or sorry, these atoms in from largest to smallest, and I gave you, let's say, and I gave you, where can I write it? Alright, let's write it up here. Let's write it in a different color. And I gave you, whoops. Alright, I gave you fluorine. I gave you sodium, boron, and neon. Okay, and I asked you, okay, from largest to smallest, order the size. Okay, so I look at fluorine, Oh, fluorine's pretty small. It's over here. Is there anything that's small? Yep. Okay, neon is going to be smaller. I'm going to go from, I forgot what I said already, smallest to largest. Let's go smallest to largest. So then, okay, we know neon and fluorine are going to have to be our first ones because they're the smallest. So we'll take that off our list. Okay, boom, boom. And then we've got the next smallest one, which would be boron, right? And we take that off our list. And then we got sodium as being the largest one according to our periodic trend. Okay? Okay, I'm not going to talk too much about this. You're going to have to know the difference between ionic and molecular compounds in terms of their properties, and it has to do with the kinds of bonding that happens. So the reason why you see all of this up here, is because of this right here and this right here, the type of bonding. So in ionic compounds, it's a transfer of electrons. Electrons are going from the metal to the non-metal. It is a transfer of electrons. So that is a very, very strong bond. And as a consequence of that strong bond, you're going to have high melting point, high boiling point, and a good electrical conductor, and it's going to be solid at room temperature, okay, because those are strong chemical bonds. The covalent bonds, that's what they're called for molecular compounds, are weaker because electrons are not being transferred, they're being shared, okay? And as electrons are shared, the bonding is just not as strong as ionic compounds. So that will give it a low melting point and a low boiling point and make it a good insulator, will not conduct electricity very well. And it could be a solid, it could be a gas, it could be a liquid at room temperature. We don't really know until we talk about the actual compound. Okay, so that's something that you do need to know. Okay, so we talked about this already, the difference between atoms, elements, and molecules. Okay, so a possible question could be something like, if I were to give you, let's say, oops, it's not changing color. All right, let's say if I were to draw NaCl. Okay, so I'm going to draw salt. All right, so I look at that, I'm thinking, okay, I remember my periodic trend. Sodium is on the far left, so that's going to be smaller, and chlorine is on, sorry, no, sodium is going to be larger because it's far left, and chlorine is going to be smaller. So sodium chloride might look something like this. Okay, and then chlorine is going to be smaller. There we go. Okay, so if I have this here, I have one molecule of sodium chloride. Okay, and I have two elements. This is actually not a very good example now that I can see. And I have two atoms. Okay, that's that example. All right, let's look at another example because this one, probably is not that good. But that is correct the way you do it. Let's say I had something a little bit more. Let's say I had this. Oops. Let's say I got, yikes. I got this guy coming here. First of all, let's name it. Okay, is it molecular or ionic? It's molecular because we have two nonmetals, so that's dinitrogen. Oops, spelled that wrong. Dinitrogen. Okay, monoxide. Okay. All right. So if I go ahead and try drawing this, I think that, okay, nitrogen would be slightly larger. Okay, so we have this as our nitrogen, slightly larger than oxygen. Okay, there's a good differential. And so we have, if we draw it out, we've got something like, okay, 1, 2, oxygen. Okay, something like that. Okay, so there's our nitrogen dioxide. Okay, now here we have one molecule of nitrogen dioxide, or sorry, I drew that wrong. Dinitrogen monoxide. So sorry, let me fix that. Okay, if I can. So it's dinitrogen monoxide. So then we have two nitrogens. 1, 2. Okay, it's supposed to be the same size, and we'll put our oxygen here. Okay, so we got one molecule of dinitrogen monoxide, and we've got 2 atoms of nitrogen and 1 atom of oxygen, giving us a total of 3 atoms. And we have, what else do we have here? We have 1 nitrogen, 2 nitrogen, 1 oxygen, so that gives us 2 different elements, okay? And we have 1 molecule. Now let's say we had this, okay? This will be my last example here. I always want to keep these short, but I end up going over. Let's erase this here, erase this, okay? Okay, and we'll get rid of this here. And we already know the name here. Okay. And let's say, okay, so let's say we got this going on. And we're going to draw some more. Okay. Now we got here. Okay. We got. Okay. So here we ask ourselves, how many elements do we have? Well, we still have 2 elements. We've got nitrogen and oxygen. Then we ask ourselves, how many atoms do we have? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 atoms. That's a 9, by the way. 9. 9 atoms. Now it just looks like, I don't know what it looks like, but okay, so it's 9 atoms. Okay, there you go, that looks better. Okay, and of course now, how many molecules do we have? Well, we've got, how many do we have? We've got 1 molecule here, got another molecule here, I have another molecule here, so that's 3 molecules. Okay, well, I hope that helps. And again, sorry that this took so long, but I hope it helps. Okay, bye.